Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 14, secant lines. Secant lines that meet inside a circle. All right, we discussed tangent, now we're discussing secant. So here we go, classwork opening exercise. So let's label everything we know. It says DB is tangent to the circle as shown. So they're telling us that that is a tangent. All right, so that's a tangent. All right, they do not give us the center being right here, so we cannot assume that BC is a diameter. Do not make any assumptions. And the reason being is if I do this, if I focus on my inscribed angle, the measure of angle BEC is 87 degrees and it's on the circle. And what do we know about angles that are on the circle? They are half the intercepted arc. So if this were a diameter, this should be 180 and this should be 90, but it isn't. We're off by 3 degrees, which is almost unnoticeable. Do not assume that's a diameter. So if this is 87 degrees, this is 174 degrees over here. Okay. Now I'm going to shift my attention to this angle. Angle B is on the circle. Angle CBE is on the circle now. It intercepts, let me use green. It intercepts, it goes up to here, starts at C, and it intercepts the arc CE. So angle B intercepts CE. Well, CEB is the rest of the circle, which is 6 degrees shy of 180. So the whole thing is 186 degrees. So the measure of arc BEC equals 186 degrees. Okay, so just make a note of that. And that is CE plus EB. So we'll come back to that. But notice that we have a secant, which is what this is called, a line that hits the circle, it goes through it and hits the circle at another location. A line that cuts a circle and intersects the circle at 2 locations is called a secant. If it just touches on the edge and is perpendicular to the radius, it is a tangent. This is not a radius or diameter, keep in mind, because that's 174. Okay. So we have this secant angle, it's intercepting this arc right here. What else can we do that we know of? Oh, right here. So sometimes it takes a few moments to identify certain things. What just happened? I'm trying to draw with purple. If I draw this here, the measure of angle ECB is also an inscribed angle, and A intercepts A intercepts arc BE. So A is 1/2 of this arc here. Okay, B is 1/2 this arc. This angle is 74 degrees. Right here. So what else do we know? Okay, so now I'm going to focus on linear pairs. CEB plus BED is the straight angle CED, which is 180 degrees. Since I have 87 here, this is 93 degrees. 93 plus 87 is 180, and this is a straight line. Now I have a triangle down here, 93 and 74. Is 167, so this is 13 degrees. Okay. Well, angle DBE is 13 degrees. It's an angle on the circle. It intercepts arc BE, so it's half. So this is 26 degrees. If that is 26 degrees, this arc BE is 26 degrees, then the measure of angle A, which cuts it, is half. So A is 13 degrees. So the measure of, or actually they call it A, so let's just say A equals 13 degrees. So now I have another triangle here, triangle CEB, and I have 87 plus 13 is 100. So B has to be 80 degrees. So B equals 80 degrees. So it would be, the key to this was not assuming that that is a diameter. They did not give us a dot in the center that it goes through. Okay, so now it says, is CB a diameter of the circle? And the answer is no. Okay, if it was, then the measure of angle CEB, so if it was, the measure of angle CEB, which is an inscribed angle, would have been half of 180 or 90 degrees. So, and it is not, so therefore it is not. Okay, so be careful, do not assume diameters. Okay. Okay, exercises 1 and 2. Here we go. Here's number 1. 2's on the next page. Okay, so it says in circle P, PO is a radius. Fantastic. So let's just label that. So PO is a radius. And the measure of angle, or I'm sorry, the measure of arc, MO, is 142 degrees. They've already labeled it. Find the measure of angle MOP. Okay, well, if this is a radius, then this is a diameter. So this one, we do not have any assumptions. They gave us this line going through the center. It is the radius. So if I extend that line through the other side, that is now called a secant. That secant, if we just went from O to this end, is a diameter. So that tells me that the measure of arc OM to here, so if I were to call this P, then the measure of arc MP plus 142 has to equal half the circle, or 180, which is 38 degrees. And the measure of angle MOP, that is an inscribed angle, it's half the intercepted arc, so it's 19 degrees. So the measure of angle MOP equals 19 degrees. Okay, page 2. In the circle shown, the measure of arc CE is 55 degrees. So let's label that. CE. Oh, they already did for us. I will color it red. There we go. CE is 55 degrees. Find the measure of angle DEF, which is right here, and the measure of angle or arc EG. So these are the two things we want to find. So I want to know what that measure is. Okay. All right. So how did CE get formed? What is cutting CE? Angle CDE. That is an inscribed angle. So therefore this angle is half the intercepted arc. Half of 55 is 27.5 degrees. Okay. So now that I know that's 27.5 degrees, look what I have. I have, now let me erase these red lines now. Actually not erase, let me move this down like this now. So these two red lines, as you can see, there are arrows on them. That means they are parallel. And so therefore DE, segment DE is a transversal. So we have two parallel lines cut by a transversal, and hopefully you remember from that part of our course, alternate interior angles are congruent. So the measure of angle DEF is 27.5 degrees. So there's our first answer. The measure of angle DEF equals 27.5 degrees. Okay, so now I'm going to focus on, now watch what I'm going to do here. Now we want to know what this is. Well, look at, if we have DE parallel to FG, now these two red lines here are parallel, and now EF is a transversal. We now have two parallel lines cut by a transversal, and once again, the alternate interior angles transfer, and so therefore the measure of angle EFG is 27.5 degrees. And that is an inscribed angle intercepting EG. So therefore the measure of arc EG G equals 2 times the angle that it is intercepted by, which is 27.5 times 2, or 55 degrees. Okay? Example A, find X, justify your answer. So here's what we're trying to find. Here is what we were given, and here is what we were given. This is not a central angle. It is not equal to the intercepted arc. This is not an inscribed angle. It is not half the intercepted arc. It's something different. And this is the first time we've run into one of these problems. So let me explain it. The way we're going to solve this problem is we're going to create a triangle. Here's triangle. Here is a triangle right here. Let's focus on this triangle. And if I just look at angle GBD, it is an inscribed angle, and therefore it is half the intercepted arc. And if this continued on, and I will do that for a moment here, so as you can see, this would continue to here. Angle DBGC is intercepted. It intercepts DC, and it's 40 degrees. So therefore this angle is half that, which is 20 degrees. Okay. So I'm going to put that triangle back like so. And the reason I'm highlighting this as a triangle is what you're going to see next is I'm going to extend this out to E. So focus on angle. Let me get this out of the way for now. Angle BDE is an inscribed angle. It's half the intercepted arc. So therefore the measure of angle BDE is half of 120, or 60 degrees. Okay, so we found 2 of these angles by the inscribed angle rule or theorem. And then if I put that back together, I now see that I have a triangle, and all triangles add up to 180 degrees. So that's the triangle sum theorem. So if I have 60 here and 20 here, that's 80. That means this angle here has to be 100 degrees. There's our triangle sum theorem. So now I can just get rid of these, and that's how we found that. Well, we have 2 lines intersecting. Okay, some teachers call this the Catwhisker diagram, and it just means if you have a straight line going this way and a straight line this way, these are vertical and these are vertical, and we know vertical angles are congruent. So if BGD is 100, then CGE is also 100 degrees. And let me get this mess out of the way here. Okay, hopefully you're following that. Now let me put back this segment right here. That is a straight line. It is formed by angle X and angle CGE. That is a linear pair forming a straight angle 180 degrees, and CGE is 100. So therefore the measure of X is the supplement to CGE. And these are vertical, so that's also 80 degrees. So I answered the question, find X. X equals 80 degrees. And justifying it, I did it verbally. Okay, so moving on to the last problem here. Here is X. 35 degrees, 28 degrees is intercepted. Again, if I draw forgot to do my straight line here. If I draw a straight line from B to D, like so, and let's make it, I don't know, blue. All right, so now I have a triangle here. No, I don't. Yes, I do. I have a triangle right here. Okay, this one's a little bit hard to draw in, but this triangle BDG is the same setup as this. I have a DBC is an inscribed angle. It's half 35. I'll have to draw an arrow because that's so small. This angle right here is half of 35, or 17.5 degrees. Okay. And then if I focus on angle BDE, it is intercepting this arc of 28 degrees and forming an angle here that would be half. So this angle here, angle DBG, is half of 28, or 14 degrees. And then I can find the measure of angle BGD by taking, so I'd say the measure of angle BGD equals 180 degrees minus 17.5 minus 14. So the measure of angle BGD equals, well, 17 and 14 is 31.5. Taking 31 from 180 would be 150, 149, and it would be 148.5. degrees. So BGD is 148.5. I can't fit it in there, but it's right there. And the measure of angle X and that BGD are linear pair. So now I'd say the measure of angle X, if you will, equals 180 minus 148.5 degrees. The measure of angle X equals, well, it's actually it's an exterior angle, so it's the sum of the two remote interiors as well, if you want to remember that formula. So it's 31.5 degrees. And there you have it. Page 3, we can state the results of part B of this example as the following theorem. Secant angle theorem, interior case. The measure of an angle whose vertex lies in the interior of a circle is equal to half the sum of the angle measures of the arcs intercepted by it and its vertical angle. Okay, so we want to find X and Y here. Looking at Y, we do not know the measure of EC. We do not know the measure of BD, but we do know the measure of arc BE and the measure of arc DC. And that is going to be, our focus is going to be the angle X. So we're going to say X equals, and it's going to be the sum of the angle, or arc measures that are intercepted. So it's going to be 150 degrees plus 80 degrees divided by 2. So when I do that calculation, 150 plus 80 is 230 divided by 2 equals 115 degrees. So the measure of X here is 115 degrees. Okay, so how do I find the others? If I drew this, that is a straight line. X plus Y equals 180 because they are linear pair. So then you'd say X plus Y equals 180 degrees. Substitute in 115 for X. Subtract 115 from 180, and it's 65 degrees. Okay. 115 degrees. Okay, I thought that was 150. 115 degrees, 65 degrees. Okay, and we're just going to keep doing that. So again, here is our angle. Here is our intercepted arc. And here is the intercepted arc from its vertex, which is what the theorem says. Or vertical angle, I mean, not vertex. Vertical angle. So then I would say X equals 42 plus Y. See what happens here? We have an unknown. So we can't solve that. And it's also going to be divided by 2, by the way. I didn't finish writing because I had noticed that. But I see this 121 degrees. So again, I'm going to point out that you have to be aware of linear pairs, straight lines. So the measure of angle X in this case, the measure of angle X equals 180 degrees minus 121 degrees because they're a linear pair. So the measure of angle X is going to be 180 minus 121, which is 59 degrees. Okay. The reason I left this here is we can now find Y if I substitute in 59. So always write the formula. The angle equals the sum of the arcs divided by 2. Now I know the angle, so now I'm going to put 59 over here where X is, and it's going to equal 42 plus Y divided by 2. I'm going to multiply both sides by 2 to get rid of this 2 here, and that is going to give me 59 times 2, which is 118, equals Y plus 42. Okay, 42 plus Y plus 42 doesn't matter. Then I subtract 42 from both sides, and lo and behold, we'll get Y to be isolated. Y is going, oops, I guess I could say Y degrees equals 8 minus 2 is 6. 11 minus 4 is 7. So Y equals 76 degrees. Okay? All righty. Again, we have an angle. We have intercepted arcs of the angle and its vertex. I keep saying vertex, vertical angle. So X intercepts CD, X's vertical angle intercepts BE. So X is going to equal 3X minus 68 plus 34 divided by 2. See, it's not that difficult. And if you write the formula, everything just falls into place as long as you know how to simplify an equation and isolate variables. So we get 3x minus 68 plus 34 all divided by 2. All right, so I want to get the x's by themselves. So the first thing I'm going to do is get rid of my denominator. We don't want to have fractions. So when I do that, I'm going to end up with 2x equals 3x minus 68 plus 34. And I might as well combine my like terms now. So 8 plus 4 is 12, carry the 1, 9, so that is 102. Okay, I then will subtract 3x from both sides. And I get negative x equals negative 102. So when that happens, you just multiply by negative 1 both sides. That is going to yield a positive x equals a positive 102 degrees. So that's 102. So since x and y are linear pairs, okay, let's make it blue again. Here is our straight line. So then my equation would be x degrees plus y degrees equals 180. X is 102 degrees plus y degrees equals 180. Subtract 102 from both sides and y equals 78 degrees. So y is 78, x is 102. Okay, I got looking at this when I was done, and this is an acute angle. How can that be 102? So when I looked at this, I made a mistake right here. Minus 68 plus 34 is not minus 102. Negative 68 plus 34 is negative 34. So let me fix this. Hopefully you caught that when I was doing it. That's a minus 34. So then this is going to be minus 34 down here. 3x minus 34 equals negative 34. So x equals negative 34 degrees. Okay, so then when I come over here, my 102 is now going to be 34. Negative 34. So when I add 34 to the other side, or I'm sorry, x is going to be positive 34. Because a negative multiply both sides by a negative, I'm going to get a positive 34. So if I subtract 34 from 180, I get 146 degrees. That makes more sense. Okay, so now my x is my acute 34 degrees and y is 146 degrees. Okay. All right, page 4 brings us to number 6, and it says, in the circle shown, BC is a diameter. So the first thing I'm going to do is label that diameter. BC, the diameter. Find x and y. All right. In looking at this, first thing I notice is angle DEC is an inscribed angle right here. So that means that this angle times 2 equals this arc. So 41 times 2 is 82 degrees. So I'm trying to find x and y. So I know the formula. I'm going to write it now. Y equals 82 plus x divided by 2. The problem with that is that we have these two unknowns and we can't solve yet. So I've got to find something else to help me out. I need more. Okay, so the next thing I'm going to focus on is, now let me move this over to here. Actually, I should have left that one and move this one. Okay, there's another inscribed angle. So this angle, 78 degrees, is half of its intercepted arc, which is right here. So 78 times 2 is 156 degrees. Okay. BC is a diameter, so therefore arc, the measure of arc BEC equals the measure of arc BE plus the measure of arc EC. BE plus EC equals the whole thing BEC, but BEC is a diameter. Okay, that's a semicircle, so this is 180 degrees. BE is X and EC is 156 degrees. So if I subtract 156 from both sides, I get X equals 8 minus 1 is 7, 10 minus 6 is 4, 7 minus 5 is 2. So the X is 24 degrees. So now I can substitute that in here. So now I'm going to write Y equals 82 plus 24 divided by 2. Y equals 106 divided by 2, and Y equals 53 degrees. And there's my X and my Y. So this is 53 degrees. Okay, so there we go. There's X, there's Y. Number 7 is a proof. So let me bring in my table, 2-part proof. Okay, so here's my statement reason. Set up my 2-part proof, column proof. Statement. So the first thing I'm going to do is list my givens. BC is a diameter. Okay, so BC is a diameter. And the reason? Given. Okay. Then I'm going to say the measure of angle DBC is X. So the measure of angle DBC equals X degrees, and that is also a given. Okay, now I'm going to say the measure of arc DC, and I'll label it as I go. The measure of arc DC equals 2X. Okay, why is that? Because, how do I word that? Arcs are twice the measure of the inscribed angle that intercepts them. Okay. The arc measure is 2 times the angle. So as you can see, angle DBC is X degrees, and that is what is cutting this arc DC or intercepting it. And then we would say the measure of arc BE, let's see, equals X. The measure of arc BE equals X degrees. And why can I say that? Here is BE. It is this right here. If DC is 2X, it's a 2-to-1 ratio, so BE has to be X. So that is a, the reason is right here in red. DC is to BE as 2 is to 1. That was sort of a given, but you want to state that. Okay, great. So now I know that that's x. So let me label that as x degrees. So it's equal to this angle. All right. So then once I say that, I say the measure of arc BDC, the measure of arc BDC, okay, equals, so BDC is this semicircle 180 degrees. Well, BDC equals BEC, okay, because it's a semicircle, so that's equal to the other side, the measure of arc BEC. And they both equal 180 degrees. And the reason is semicircles measure, sorry about the poor writing, it's hard to write with this pad. Semicircles measure 180 degrees. Okay, so moving along, now that, what do we have? We know now that BDC is equal to BEC. All right, and now we're going to do some additions. So what is DB? The measure of arc BD equals, well, BD is right here, and this was 2x. I didn't label it. I should have. That's 2x. So the whole side, BC, is 180. So BD is 180 minus 2x degrees. Okay? This whole arc BDC is 180 degrees. You take BDC minus DC and you get BD. So BD is 180 minus 2x. That's arc addition. Okay, we're adding a negative, but that's arc addition. And then we can say the measure of arc EC, that's over here, the measure of arc EC equals 180 degrees minus x degrees. So this is this little red arc taken away from the other semicircle, 180 minus that. So if BD is 180 minus 2x and EC is 180 minus 1x, that is also arc addition. I'll just use ditto marks. Now, what is the measure of BFD? Here is our angle BFD is right here. It is Y. Arc BFD is angle Y. Okay. So now I'm going to say that angle, the measure of angle BFD equals 1/2 BD. Well, BD is right here. So it's going to equal 1/2 180 minus 2x. All right. Arc BFD. And it's not a central angle, so we're not done. It's the sum of the two. That's what we've been doing in this lesson. So this angle Y is 1/2 this arc plus this arc. So this is 180 minus 2x, and then it's going to be plus EC, which is 180 minus x, which is actually pretty cool how this comes together. Okay, and measures of an angle whose vertex lies in a circle is half an angle measure. So let me bring that in. It's a lot of words. Okay, so the reason I can say that is right there. It takes a while to write this, so I just brought it in. Measure of an angle whose vertex lies in a circle is half the angle measures of the arcs intercepted by it and its vertical angle. All right, which is what we've been doing in this lesson. So let me extend this a little bit there. And now what can we say? Well, now I can say Y degrees equals. So then I'm going to combine all this. So let's simplify it. 1/2, 180 plus 180 is 360. Negative 2x minus x is minus 3x. So then when I simplify that, I get y degrees equals 1/2, or not 1/2. I'm gonna distribute that half, and that's going to come out to be 180 minus 3/2 x. And that's substitution. And what were we trying to prove? Prove that y equals 180 minus 3/2 x. So there it is. Whoop. Okay, page 5 brings us to the end of lesson 14. Review the lesson summary, secant angle theorem, interior case, and the vocabulary, and go to your problem set.